So in this video, we're going to work through the umbrella of packages called Tidyverse, which is an amazingly powerful package or collection of packages, and really the language for solving data science challenges within R. So Tidyverse, it's a collection of R packages designed for data science. They all share this really underlying design philosophy, grammar, and data structures. And these packages are really designed to support the natural workflow of any data analysis project. From importing data into your R environment, cleaning it up, transforming it, creating some sort of model, to then visualize and finally communicate to constituents, stakeholders, what have you. It's very powerful, and what I use really every day. So this is just kind of to show you a lot of the packages under Tidyverse. We're going to work through most of these here and just provide you a little bit of a background for what each of these are used for. Okay, so again, we're going to work through that natural workflow of data analysis. The first thing you're probably doing is reading in data. And so within Tidyverse, we have this package called readr. And how this series of slides are going to go is we're going to provide a purpose on the left and show you some of those functions that are most used within that package that I think you'll be using the most. So like its name, readr is used to read data into R. There are many formats of data that you can read in terms of tabular data. We're just working with tabular data here. There are many formats that you can read into R: CSV, Excel, text files. I would suggest converting everything to CSVs. When it comes to Excel, there's sometimes some errors that come up. read_CSV is really the most used function here that reads in comma-separated files. So if that requires you to, within Excel, convert something into a CSV, I would suggest that rather than trying to read in Excel. It is possible. You can see there's a read_Excel function here. But for the most part, CSVs is really the common practice. Okay. Really simple when it comes to the readr package. And something that you'll notice, there's going to be a pattern here. Each of these packages within Tidyverse have what's called this cheat sheet, and it is extremely helpful. It's usually 2 pages, and it just works through some of the functions that are within the package, the arguments it requires. I've provided the link here to each of these cheat sheets to help you out, but I really, really recommend working through these. So something that actually I didn't point out in the previous slide is not only can readr help you read in data, but also write. So say you manipulated your data set, and on the back end, you're ready to output a new transformed data set, and you would be using write_CSV. And usually the arguments are the data frame in which you wish to write to, say, a CSV file, and then the next argument is the file. So that includes the file path and then the file name, and make sure that you have the .csv at the back end of that file name. Okay, great. So pretty self-explanatory when it comes to reading in data, although I will say new R users do tend to have an issue with reading in data, and that's really because the path name. So ensure that your path name always is exactly correct. That leads straight to your file. Okay, so say you've read in your data. The first thing that I always suggest is inspect the data. Take a quick look at it, try to make sense of it. Here are some functions that you can use to just really understand what this data contains. Within R, you can view a data set, but say this data set is millions of rows long, it is going to slow down your computer. And so here are some functions that you can use to kind of understand what this data is without opening up that data set. So the function names, the argument in each of these is going to be the name of your data set. So if you say names, df1, that returns a vector of column names. So all your variable names. So that's just really just nice to know, like, okay, I've read in this data set, it says it's 10 variables long or 10 columns long. What are they called? What exactly is this data? Names. First and foremost, that's what I do. Head or tail returns the first or last parts of in our object, in this case, a data frame. So it will give us, say, like the first 10 rows, 6 to 10 rows of the data set. So there's, again, after names, after knowing what the column names are, I like to do this just to see what the data looks like. Again, you can view the data just by clicking on it and then having it pop up. But again, if your data set is so large, this is another way around that. The str function, structure, is what it's short for. This allows you to look at each of the variables, what the data type is, whether it's character, whether it's numeric, and just provides a short vector string of what's in those columns. Summary produces this basic summary statistics for each of the columns when possible. It provides the min, the first quantile, median, mean, third quantile, max, and the number of NAs if present. You can imagine these summary statistics will not work on character or factors because it is text. So in that case, it'll just give you, I think, the output of the length of rows. If there are NAs, it will produce a number of NAs. Okay, and then there are ways to investigate individual variables. So in this case, what is your argument is not just the data frame, but it's going to be the data frame and the name of the variable you're interested in investigating. So this is where that money sign comes in. You would say, for instance, this unique function, which would return all the unique elements within a vector. So we would write unique parentheses df1, if that's what our data frame was called, money sign to index the data frame and whatever variable it is, var underscore 1. And that would output only the unique elements within variable 1. This is really helpful when you have a column with text or with character, that is a character type. And you can imagine it's repeated across rows. You can then start to look at, okay, what are the just unique elements within this column? Okay, so that's really helpful when it comes to character or factors. When it comes to numeric variables, I really like to use what's this function called hist, which is short for histogram. And this creates really quickly and really roughly, it's not a pretty figure, but if you throw into the argument the variable name again, it'll create a histogram of the values within that column. And that helps you understand the general distribution of the data within that column. Again, just really helpful to understand what the values look like throughout your entire data set. Okay, finally, I don't use this as often, but there is a function called pairs, and this produces a matrices of scatter plots with each single variable paired with each other to look at how they correlate with each other. Again, the figures aren't beautiful. It's just really a coarse, like, let's just look at what this data is showing us. Quick way to look at, are there correlations across different variables and what? So just another handy function to inspect the data. But again, all of these functions I use quite regularly. Once I read in data, I use these just to grasp quickly what I'm looking at. before I start to manipulate things, because this will help me indicate, oh, there's a lot of NAs. I want to get rid of those NAs. Or if you use unique and you see that there's these two unique elements should actually be the same, but one was misspelled. This helps me to identify some errors within the data set that maybe I need to fix, which then we'll use other packages within this Tidyverse world to manipulate, wrangle, and clean the data. So speaking of, the next package that we're going to be working with is dplyr. And dplyr is probably one of the most used packages that I use when it comes to data cleaning. It has a host of functions that perform specific and very incremental data transformation steps to help you wrangle your data into exactly the right form you need. So to the right here are the general functions that you probably will be using when it comes to data cleaning and wrangling. And what's beautiful about dplyr and really the Tidyverse in general is it's quite intuitive. So the filter, or excuse me, that's what I'm getting to. The function names do exactly as they sound. So for instance, filter, this function helps pick out observations by their values that you are interested in keeping, as opposed to select, which allows you to select the variables. So filter works on rows, while select works on variables or columns. Okay. If you want to create new variables or edit variables in any sort of way, this is where mutate comes in. So you're mutating a variable, whether that's an existing variable or you're creating a new one. Rename is another function. Like it sounds, you're renaming the variable. You're renaming the column name because you didn't like what it was called for some reason. And these last few here, there's arrange, which means you're reordering the rows of your data frame based on some variable. Maybe you wanted it in descending order based on variable 1. That's where arrange would come in. And then finally, if you want to collapse your values into some sort of summary statistics based on another variable, this is where the group by and summarize, they usually are paired together in some way. So for instance, say you have a data frame, you want to group by this variable that has 3 different categorical groups. And you want to take this, you want to summarize that and take the mean of each of those groups on a different variable, on a continuous variable or numeric variable. This is where group by and summarize come into play. Okay. Another thing related to dplyr is combining data frames, and there's different ways that you can combine data frames. You can bind data frames by columns. So you can see here, if you're just literally combining columns, it's just like a C bind in what is called basic R. But it's really just pasting the columns from 2 different data frames together. You can do the same thing by binding rows, but now you're working in the opposite dimension. You're literally just pasting different rows from different data frames together. Then there's what's called mutate joins. And this is really where you're matching values within the rows of these 2 data frames and ensuring that they correspond to each other. And so this actually is, I use this a lot more than combining variables or cases. So this is where you have, say, like reference variables that you want to match from 2 different data sets, and you want data in data set 2 to come over to data set 1, but it's really case specific. So this is where you can use left join or right join, and that really just means whatever argument comes first, you're going to join argument 2 or y to x, which are data frames, and then you're going to indicate by, which is the variables that you want to be matching and corresponding to each other. Left join and right join keep whatever is in that argument. So left join keeps all cases in X and only cases in Y that match X. and vice versa with right join. Inner join, hopefully now you're catching on, inner join is only those cases that are seen in both X and Y. And then finally, full join. You'll have all cases in X and Y combined. Anything that doesn't match will have an NA in those new columns that are being joined from data frame Y. Okay, so it really depends on what you want as the output is what function you'll use here. And when you're using inner join specifically, I just warn you, just be careful because it's only joining what matches, you lose what doesn't, and sometimes you want to see what's going on. So I would suggest using a left join or right join until you know exactly, okay, what's not matching up, because sometimes there could be some user error in some of those other variables, then you can move to an inner join if that is exactly what you want. Okay, so like the package before, readr, dplyr also has its own cheat sheet, which is very, very helpful. And it goes through some of the functions that we worked through in the previous slide, but a lot more. Again, it's like a 2-page cheat sheet, and I provided the link here. Okay, so the next package that we're going to work through is Tidyr, and this helps to reshape. It does a lot of things, but really it's just reshaping untidy data into more tidy, in air quotes, data. There are 3 interrelated rules which make a data set tidy. Each variable must have its own column. So we know this. This is really review at this point. And each observation must have its own row. Okay, so variables work as columns, observations are rows, and then values are each element within a given row and column. Okay, so to the right here, we have the general functions. Pivot longer and pivot wider, I think, are the most, those are what I use the most when it comes to the Tidyr package. Pivot longer allows you to reshape data frames from wide format to long format. And what I've noticed is data sets that come from the field, from surveys that are done in the field, they're usually formatted in wide format because that's what we as humans think. But that's actually not how Tidyverse likes it. And when we get to visualizing ggplot, ggplot loves long format. So pivot longer is used, at least for me, it's used a lot to get data into the format we need to then visualize. Pivot wider, the opposite, reshapes data from that long format to wide format. A few more functions here that are helpful. Drop underscore NA helps you to drop rows with NAs within a given column, per se. And then finally, replace cells with NAs with a defined value. So for some reason, you wanted to replace NAs with the number 9999. This is what you could use this function, replace underscore NA, to do that. Okay. So like all the rest, here is the cheat sheet for Tidyr. Again, extremely helpful. I just worked through a few of the more of the main functions within Tidyr, but there are a lot you can see here. Okay, so next package, stringr. So the purpose of stringr is really to manipulate strings, character strings, using concise and more intuitive language for describing patterns in strings. This allows you to detect matches, subset strings, manage string lengths, mutate strings, join and split strings, and order strings. This, I think, by far is just like so much better than base R. Base R, when it comes to operating with strings, it was so counterintuitive, really didn't make sense to me. This, I think, I mean, Tidyverse is amazing in general, but I think working with strings in particular, this was really a great improvement to working with strings in R. So some of the general functions within string R are listed here. We have str_pad that helps you to pad strings to a constant width. I think the best example here is, say you have a column for month, and you have some months 1 through 9 that just have the number 1, while you have other months like October, November, December that have 2 digits. Say you wanted, for some reason, for like future manipulation, you needed a 0 in front of those earlier months. Now you can pad that column with a 0 using this function here. So it's really, really easy. str_which, this next function here, that helps you to find the indexes of strings that contain a pattern, and match that with str_which. So something to point out here is this is just finding the index, so the position of the string in which you're trying to match to. str_sub, which I think is a bit more helpful, helps to replace substrings by identifying the substring with str_sub and then assigning it into some new result. So you're substituting something that you're asking R to look for within a column, per se, and then substitute it with something. And then finally, replace. Replace the first matched pattern in each string with str_replace. Okay. So again, there's a cheat sheet here. I've just provided some of the main functions within Stringer that are most used, but there are a lot. And then the link there to the cheat sheet. Okay, just a few more packages here. The next package is what's called Forecats. This helps to provide a suite of tools that solve common problems with factors, including changing the order of levels or the values. I don't really use these functions that much, probably because I'm just not comfortable with them. I'm still using base R. So anyways, they are still helpful, especially the factor reorder, this first function, FCT_reorder. This helps you to reorder a factor by another variable. You can also reorder a factor by frequency of values, which is actually quite helpful when it comes to thinking about when you want to visualize data. So you would use the FCT_infreq, short for infrequency or infrequent. Say you wanted to change the order of a factor by hand, you can use the FCT_relevel, and you would give it the new order in which you wish to order that factor variable in. And then finally, collapsing the least most frequent values of a factor into other. This is really helpful, which I need to use more of, because you can imagine you're trying to visualize, say, a bar graph of data by maybe species, and you have hundreds of species, but really there's a lot of rare species. You can use this to help collapse those species that are infrequent into this other category. So that's what FCT_lump would do. So again, here is another cheat sheet that works through some of those general functions that we've walked through, as well as a few others. And we're going to stop there. So now we've gone through all of the functions and packages that you would use to read in data, clean, wrangle, transform, and up next we will work through visualizing data.